All right, let's see. Hopefully everyone is seeing me right now. We have people popping in. I'm going to go ahead and turn on a screen share really fast. And let's see if this works the first time. Great. Okay, perfect. Yeah, thank you everyone for making it today. I hope you've been having a lot of fun with the conference. If you've seen a lot of the sessions so far, this is our last day. We're going to have a festival today where we're going to show off a bunch of activities using virtual manipulatives. And these are activities coming from the masterclass.org website, as well as the Julia Robinson Math Festival website. So we're going to have a bunch of different tables with a bunch of different activities. And we just hope everyone's going to have a good time. I'm going to talk a little bit about how this is going to work. So if you look on my screen share, you're going to see a few sets of different tables, and then you're going to see these activities in the bottom. So all of the activities are going to be accessible through, let me make sure that I pull this up correctly. Sorry, 1 second. Okay, so all the activities are going to be accessible through these buttons on the bottom. So for instance, if I wanted to try out wolves and sheep, I can click on wolves and sheep, and two things are going to pop up. I'm going to see a video with rules that I can play and watch for the rules. If you're going to watch any of these videos with the rules, we kindly ask that you either use headphones or you mute your microphone using this button right here. So if you can do that for us to watch the video rules, you can also access online manipulatives. And how this is going to work is that you're going to click this button right here called Google Drive Slides. It's going to ask you to make a copy. And we're going to do this so that you can make a copy of the activity to your personal Google Drive account. And we're doing this so this way everyone can have their own copy and we're not messing with each other's document. I think anybody who's done any kind of collaborative Google Docs knows the problem here. So after just a second of loading, you're going to see something pop up that looks like this for any of the activities. And the document's a little funny. You can't play with any of the text in the background. Every one of these documents is going to have its own set of virtual manipulatives. In this case, we have wolves and sheep tokens. And if I go to my slides, I'm going to have different problems. When I look at the problem, I can go ahead and try to follow those with the rules and then use my virtual manipulatives to see if I can play along. If I look back in, down on this bar, we see a bunch of different activities. Again, I can go ahead, click, and I can make my own copy, which, I think that this one's actually not labeled correctly. I think we'll have someone on tech support fix that really fast. So let me go over to Witches Cauldrons. So if I go over to the Google Drive link, I can go ahead and make a copy. And I can see that I'll get a pop-up again with its own set of virtual manipulatives. So I can go ahead and use these to answer the problems. When we look at the floor mat, we're going to see that there are a bunch of different tables that correspond. So if I want to work on wolves and sheep, I should go to one of the two wolves and sheep tables, which you can kind of see right here. So wolves and sheep, or if I wanted to go to magic squares, I go ahead over to magic squares and so on like that. If you have any questions, we have support staff from AIM who are going to be able to bounce between the tables and answer any questions you have on the tech side of things, as well as answer any questions to get you started on the activities. I'm going to go ahead and drop the presentation mode so we can go over to tables. I think I'm going to kindly ask that until things get a little full, if we could try to focus on just being at the top row of tables, just so facilitators don't have to bounce around too much. And again, as always, if you have any questions, feel free to message me with general chat or see if you can find your AIM staff at the table who can maybe help you out. All right, thank you very much. And let's drop back to tables.
Oh, I guess we're not really playing against each other. I guess we're working cooperatively to fill in the grid correctly, right?
Yeah. Let's put like 5 in the middle. And I'm just, because that's average, you know, I'm just like, I don't know, but let's just see if that works.
I mean, that makes sense as a starting point if we want everything to work out to be the same. So, so then we're just going to have to maybe like pick a number and put it somewhere, right? Like,
yeah. See, because I'll tell y'all what I was thinking, but it won't work.
It's okay.
So, 9 and 1, 8 and 2, 7 and 3, 6 and 4, right?
Yes, like, totally,
10,
right?
10, 10, 10, but that won't work.
Well, it will. It's just where do we put those pairs so that it adds up correctly around the side?
Oh,
right?
Yeah, I see what you mean.
I think that is an essential component, but it's not 100% random, where as long as I put a pair, then everything's good, because that will make all of the, I'll call them diameters. That will make all the diameters work, but then around the outside of the magic square, we've got to be strategic about our placement. Does that make sense?
Yes.
So I think the 9 and the 8, because they're so large, can't be on diagonals, because then they'd have to match a horizontal, a vertical, and a diagonal.
Okay.
So
So
it's like they have to be the middle up and
Like
down, and the middle
9.
sideways.
and an 8, like something like that.
Yeah.
Okay.
Respect.
But then, so if this is a 9, then we are saying across from it should be the 1. And if this is the 8, then across from it should be the 2.
Yeah.
Right?
Mhm.
All right. So now we need to be strategic about how we put the others.
We need over that 2, you need a big one.
In this top right-hand corner?
Yeah, I think you need a big one because
But then it can't be too big, because if we add it to the 9 going across the top.
Mm-hmm. So okay, so far we're 15. 15 is our magic number.
Mm-hmm.
So
Can I make a suggestion?
uh-huh.
That we actually do slide this into a diagonal, so that like the 8 and the 1 and the 9 and the 2, you know what I mean? There's a little bit of balance between that one really big and that one small one.
Yeah. Okay, well, so then it would have to go 8, 1, 6.
Okay.
Right? Have to.
So 8, 1, 6.
And then on the top row it would have to be 2, 1, 4.
And then that has the 4 and the 6 across from each other.
Whoop whoop.
And it has the 15, right, in all of those places. Okay, so then for 15 on the left side, that would be the 3.
Yeah.
And then that leaves us with 7 over here. Is that also 15 on the right? I think it is.
We're so good at this.
All right, go team.
Yay!
So I looked at the next slide, and it looks like all the numbers on the next slide are the same, except offset by 1. So I think we can cheat and use this.
You totally can. Just increase everything by 1.
Yeah.
Right? And then it's all good. All right, look at that. We used our math knowledge to skip ahead to the problem on the 4th slide.
And this one's just shifted up 7.
What, 7?
Yeah.
I looked at enough to see because I can't really see them all. Are they?
The cards or
Yeah.
the?
Because I can't see all the cards. I can only see the 8.
Oh, that's true. Here.
It just goes 8 through 17.
9,
Oh.
10.
It should actually be
11.
8 through 16. And I think the cards have 8 through 16, but we'll see if that
Then
was
the same idea, right?
That would make sense.
It does.
13, 15, and 16. Yes.
okay.
Okay. So the question is, do we want to try this without cheating and just adding 7 to all of them? Do we want to see if we can reproduce our logic?
Sure.
So then we started with the average in the middle, and so that would be the 12, right?
Mm-hmm.
Whatever
12's
the
our
middle
middle.
was.
12's our middle card in this case. Well,
And that's just plus 7, right? Of 5.
Yeah.
7 plus 5, right? So you
Yes.
just go plus 7 to all of them.
I'm doing something and it's moving weird stuff. I don't know what's going on there, but
This is so
There's
cool.
a-
that you can
there's a
move.
phantom card here that doesn't really belong there. Okay, that's even weirder. Let's not do that. There's a phantom card here. Ignore this. I don't know what's going on there, but
So we had our middle in the middle. We had our largest on top of that.
okay. So 16 here,
And we had our
Which then
smallest on the
makes-
bottom.
smallest here. and makes our sum 36.
Yeah.
Right? Okay.
We had our second largest in the bottom left corner.
Where it already is. That was easy. Okay. And so then the 9 comes up here and covers up that weird phantom card.
I like thinking about it like second largest. That's cool. And so
Interruption.
oh,
Don't go outside.
So then we said it's going to have to add up to 36 because of this center row. So 15 and 8 is 23. So that should put a 13 here. And
the
16 and 9 is
together.
25. Yeah, is 11. Okay. And so then
36, so the 10 on the left and the 14 on the right.
all right. And I think we've verified everything along the way.
36.
Does the diagonal 11, 12, 13? Yeah.
Yep. I checked that one. 36.
Okay.
I didn't check the
And then
other
the
direction.
9, 12, 15, that's 27. Yeah.
1, 15, yeah.
Yeah. Okay.
but my husband just interrupted to let me know that he hit a hornet's nest outside by accident. Ah, he said, "Don't go outside." But tomorrow,
Is everyone okay?
you know what? He's really smiling about it. And tomorrow's my birthday, so between us, I think something like just arrived. Like there's some iffy, sketchy stuff going on, but I won't go outside. I'll be good. I'm here with you. So
There you go. That's right. Okay, so challenge problem number 1. I don't know if you guys can read this. Is it possible to build a magic square for any 9 consecutive whole numbers?
Yes.
Right. If so, answer the 2 following questions. Give an expression for their magic number. And find an arrangement that makes each row, column, and diagonal sum to that number. Make an example by writing on these cards, by double-clicking on them, and typing the numbers you would like. All right, so
Could we
I'm
just
sorry.
start with like X and then X?
Yeah.
Yeah, let's be cool.
That's what I was thinking. I was like, this right, the center number is always the key. So I was just gonna let that be X, and then we have plus or minus whatever.
Ooh,
Plus or minus
okay.
up through 4, right? All right, so I can double click on here and make that X.
Ha.
Okay, and then we made our biggest one up here, right? That's how we were doing it?
Yep.
And so then this would be X plus 4. And so then its counterpart came down here and it was X minus 4. And then our second biggest one was down here. Is that correct?
Yes, correct.
Okay. So X plus 3 here. And doing it this way, like, also makes it make sense why they get partnered up, right?
Yeah.
Like maintain the balance with the plus and minus of the same amount. So
it's always 3x, right?
Oh, that's true. Yeah. It's always 3 times that middle number. Okay. And then what were the last 2?
Bottom right was X plus 1.
Okay. X plus 1. So then this becomes X minus 1. And then that would make this one X minus 2 to balance out the left side.
Yep. And that works with the numbers.
And then X plus 2.
Minus 3 plus 1 plus 2.
Yeah.
Cool.
Okay.
Use green instead?
Well, I wonder what happens if
so. I think green, you do your greens across 5, 6, and 7, and then you have the same pattern as your 1, 2, 3, 4, and you just repeat that for the top of it, right?
Right, you repeat it. I get it. Oh, did Mary Patricia leave?
No, I was trying to pull my tabs out. Yeah, I'm trying to pull my tabs out so I can see y'all and see the game same time.
Yeah. So I think Christina's right. This is what we do. We put the green here, the green here, the green here, And then there are two sort of stacks. Do you see? There are two triangles with
The 1, 2, 3.
1, 2, 3 triangles. 1, 2, 3 triangles. And both of those we only have to use 1s and 2s with.
Yeah.
Does that make sense? Yeah.
I think so.
Okay. So that's a few different, I think, because with a 1 and a 2, you can make a 1 only one way. You can make a 2 only one way. You can make a 3 using the 1 and the 2.
Yep.
And then all that we need beyond that is a 4. And then we're set.
Yep. I agree.
Cool. Shall we see what the next puzzle is?
Oh, yeah. Having them both in the same color eliminates the diagonals. Good. I like this.
That works.
And,
I like that. I
and
like
there
that.
could be other solutions too.
I like that.
Sure.
Like you?
I don't know how to get rid of my bad fractal screen, but
Is this safe?
Hmm?
No.
No, because you got a diagonal there.
you have a
On the
diagonal on the bottom.
I
On the
know.
bottom.
Yeah. So then this is safe.
Yeah, that's where I started.
Yeah,
I
if
was
you
like,
saw
all
this-
sorts of safe spots.
If you
for
saw
sure.
that over,
Yeah.
it worked.
Should we think of various solutions for this problem or move on to the next?
Anyone has other solutions you want to share? Angela, do you have another solution?
No, I do not.
Oh,
I
okay.
haven't come up with one yet.
Oh, okay. Okay, so I think, let's see. So Julie, your solution is it the same? Sorry, I missed that. Is it the same as Mojave?
Well, Julie helped me get here, so.
Oh, okay.
Yeah,
Okay.
and actually, yeah. That was.
Oh.
Yeah, and I think there was more than one way to do it. But
Yeah,
Yeah.
I mean, we
Yeah,
could
you
have them
can
both
make it
on the
quadrant.
purple squares. There are various symmetric options to this placement.
Sure.
Yeah. So I don't
Okay.
think we need to talk about the
Gotcha.
symmetric option.
Yep, that's fine.
Okay.
So let's move on to 3.
Wolves, yeah. 3
Yeah.
wolves and 2
And
sheep.
And we can work on it on paper or on our own screen and then come back here to talk
Okay.
about.
Sure.
Okay.
Interesting.
Yeah.
That I think the 1, wherever we put the 1 and the 2 kind of determines how many consecutive numbers we can place in each side. Does that make sense?
You're thinking along the right track. Yeah.
Like we cannot put consecutive numbers on the left and we can put up to 2 on the right. So I think that's why that's a good strategy to start with the 2 and the 1 there, because that means on the right we can put up to 3 consecutive numbers.
That seems reasonable.
Guess I'm just trying to think why that's, because I think that did optimize what we did with 2.
Well, there are more evens than there are triples of 3, right?
Uh-huh. So I think, so is it better to go with the 4 on the right or the left if we start there? I would think the left, but I don't know why. Because now I can get 5, 6, and 7. I've kind of like totaled up the sum here over here.
I was wondering, because there's different scenarios in each of the slides, maybe going to a few other scenarios will start to make other things become a pattern that you notice. That might be, maybe leave it for now, then go to the next one, and then go to the next one. So the second slide, as I mentioned, there are 3 cauldrons, same idea. The third slide, you've got to start with the number 2, not the number 1. See if that makes a difference. And then the 2 cauldrons. And then I think the slide after that is, let's see again. Slide after that one shows a scenario with 3 cauldrons and the same idea. So you're building up the number of cauldrons and number of scenarios here. But so 3, oh, I'm sorry, no, the next one would be,
I got to 18 on 3 cauldrons just by trying to like fill to the left as much as possible.
Yeah, right.
So it's like the easiest. So there's probably a more clever way to do it.
Go ahead. I'm sorry.
I just noticed that the rules on this first one is that it's just if any 2 numbers add up.
Right.
I was thinking, I was thinking you could not put 7 in here. I like the idea of moving on, but because I think in 2 slides it's saying if any 3 numbers add up.
Right, down the road, it's going to say if any 3 numbers. So slide number 3, I'm sorry, slide number 4 is if any 3 numbers line.
Yeah.
Yeah.
Okay.
So that adds some more depth to that. And then.
And this is still if any 2 numbers.
Right.
And I think you can get a lot higher with that, obviously, because it goes to 30. It's giving it away.
So each one of these scenarios adds a different element to it. So it gets more and more interesting as you go, I think. And maybe there's some pattern you start to notice all the different ones.
Do y'all want to try the 3 cauldrons?
How high did you get, Sarah, on the 3 cauldrons?
I got to 18. Without trying to be super clever.
Right.
And then later you'll have, at the very end, you have another situation very similar where you have the cauldrons where you start with the number 2, but they have to add up to 3 numbers. I mean, 3 numbers add up to another number. What's the large? So. So one of the questions or the challenges to think about is as more cauldrons are added, are there any patterns to help you determine which numbers can be placed inside the cauldrons without exploding?
Your pairs will always both be the same parity, right? Because it's a even number. The magic number is even, so even plus even or odd plus odd. We know that.
Right. That's 18. That's 14. 18. Shoot. This. Y'all tell me if you don't want me to move things, because I know I'm screen sharing, and so if you're like looking at the board and trying to figure something out and then I start moving cards, that's got to be really jarring. So please let me know if you need me to just leave things alone for a minute.
10, You're good. I got 34. Yep, I'm using pencil and paper too. 20, 22. That's not going to work.
14, 18, 19, 17.
Curiosity, how is the virtual manipulative working? Like, is this something that you could see yourself using with your students?
Yeah.
I think there's a little difficulty because sometimes frames go away without the card.
Yeah, there was one time I picked up a card and the number got left behind in the stack because I was taking cards from the middle of the stack.
Yeah.
But that's especially here where we're tight on space, and I don't have it full screen, so things are kind of shrunk, and I had to be really careful about where I was clicking to drag. But considering that happened once or twice out of multiple moves, I think it's working pretty well.
Yeah. Do any of you, so I went to Chris's Desmos sessions, both of them, and learned about card sorts, which was super cool.
Yeah.
Does anyone know, since like that's my first introduction to Desmos, can you give a frame like this so that you can make a card sort and then they place it into a frame?
You can post a picture and make it so they can write on the picture. Do you know what I mean? So I'm not sure you could move anything around, maybe with the computational level, but you can put in a picture as the like in the graph, and then and they can just even draw on it.
Yeah. I talked to Chris about this, and because once I saw Chris's Desmos, I talked to him about like doing this in Desmos instead. Let me actually, he actually mocked something up, and I'm trying to decide if it's like better doing the Google Drive setup or if it's better doing it in Desmos.
This is pretty cool though.
Yeah.
My dad would like this. He likes to play poker. Could play with his friends maybe that way.
Erica, I've never worked with Desmos enough to know for sure. I feel like I've only seen card sorts that other people have created, and it was just a blank background so kids could click and drag as they needed to just group everything together. That the emphasis was getting the right group together wherever it ended up on the screen.
Yeah.
Okay, I'm not sure I'm sharing the right link. I don't know how to share Desmos links well, but I just shared something that Chris made, and this is like his version of one of the activities I did. I'm trying to decide if this is something that we like more than the Google Drive kind of setup. So this is for one of the other.
I'm going to stop sharing my game board here and check out.
And is that a promising? Can you see any way of making that a promising thought for the 4x4?
I could do it, but it would take a while. So I would like start.
Yeah.
I would start with like ones, and try to eliminate. There's, I think, all right. So I got 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I have 17 different ways to make it with a 1. So something that would work, but it would take a long time, would be tried to eliminate those possibilities one by one. But that would take a long time.
Well, the ones without using that in a hard and fast way like you did with the 3x3, the ones that are most constrained, a 1 for example, and 16 on the equivalently, those probably should be on the edges, because everything they're in they constrain, and the edge cells, the ones not in the corner and on the outside, those are only in 2 sums. So it kind of suggests that let's see how many there are, 8, 1 through 4, and 16 down to 13 should be on the edges.
Do you think you could use them to balance each other out? Kind of like putting putting 1 and 16 in the same row or same column or something like that.
Yeah. I suspect if we did that, it would be way too easy. I mean, that's first what I thought, but not going to have perfect symmetry here. We may do it approximately. So 16, not across from 1, but across from 2, for example.
I got another idea.
Still too many options, when you try to do it symmetrically, there's too many options that open up too many variables.
Mark, what's the idea?
Look at it mod 2. So, in other words, try to find solutions.
That's a brilliant. I don't know if that's helpful, but it is a brilliant idea. So the sums are all
make a template.
Sums are all even.
Only working with evens and odds.
So
then, like, find templates that work where you have the same number of evens and odds. So I guess you'd have like, 34 is an even number, right? So to make an even number, you have to have all evens, or 2 odds and 2 evens in each row. You couldn't have 1 odd and 3 evens. And you couldn't have 3 odds and 1 even. You're either going to have all evens in a row. So that would eliminate. So if I looked at that, it would eliminate some of my ones maybe. So right now I have 17 ones. I might be able to eliminate some of the possibilities by looking at it mod 2.
So even though that's promising, I wonder if we might get more traction with the same idea by looking at it mod 4.
Yeah, mod 4. Mod 2 would.
So it's like saying we have 4 copies of the numbers 0 through 3, and we need to make our rows and columns and diagonals add up to 2, mod 4.
All right. So I don't know if there's a system. So I'm going random.
The multiples of 3 are not going to work.
Nope. 1.
We could go 1, 2, 3, 4, 5, 6.
6, 7.
Nope.
10, 16, 17, 18, 19. Okay. No. 14. No, 14 can't go in any of them right now.
You know what? It's how maybe it's how far they're apart.
Mm-hmm.
So like these were both 1 apart, and so that meant there came a time where I couldn't do these both 1 apart. So maybe we could do like these 2 are 1 apart, okay? And then let's do sorry, this is oops. Now so and then let's do 1 apart, 2 apart, okay?
Mm-hmm.
And then I want this to be 3 apart.
Okay.
Okay. So now I need the 6 to go 1, 2, 3. This will be 4 apart.
Okay.
I don't know. Let's just see. Okay. So 1 apart, 2 apart, 3 apart. 4 apart. I know I'm not doing it in order, but
Okay.
and then okay, and then my next is I'm just trying to keep them.
Yeah.
I'm trying to keep them like cicadas, you know, like a prime number away from each other or something. Just trying to keep them so they don't cycle back on each other.
8 has to go, I think, in the right hand cauldron.
Okay. Okay.
But
Maybe-
9 can go in the middle cauldron.
Okay. But
Which
now,
would be then-
now I've lost my.
Yeah.
1, 2, 3. Oh, maybe you go 1, 2, 3, but then you go 3, 2, 1 instead of getting farther and farther apart.
Mm-hmm.
3.
Okay.
There's
5, 6, 7, 8.
I can't put 8 there. Oh, okay. Well, that's okay. Whatever it is, I'm gonna make. No, I can't make it 1. So let's see. 3, 2.
Mm, 11 won't work there. I think 11 needs to go in the middle because of the 7 and 4. 11, okay.
Okay. 13 can't go here.
Mm-hmm. But it can go either of the others.
Can go in
Mhm.
either. Yeah.
Yep.
Yeah, so 13. But I can't do 14 because these are
Nope.
1 apart.
We don't want the 7 to be with the 10. Oh, maybe we can. Uh, 6, 2. I'm just doing this randomly.
Great. So I hope everyone had fun. We are unfortunately out of time. So if you want, you can kind of like, feel free to use any of these manipulatives that we had on the bottom bar. Again, these are all things that you can copy to your Google Drive, and just as easily you can kind of share that in your Google Classroom or your Canvas, or share just with direct links to your students. We're going to be trying to work on more of these activities before the fall comes out. But again, we just hope you had a good time. We have one more presentation of the workshop. That's going to be pile splitting with James Tanton. I believe someone from tech support is going to paste a link in the chat. But as always, you can find a direct link to this on our mathcommunities.org page. Thank you again for attending. I just want to say it means a lot that you're all willing to kind of like take this time out of your summer. And I know that it's really... it's been a long week, but I think there's been a lot of great sessions throughout it. So I think we're going to go ahead. We'll leave the tables open for maybe a little bit longer if anybody wanted to kind of like do a little bit of chatting with the people they've been talking with, if you wanted to kind of ask any questions of the AIM staff. But yes, I see that both links are shared for James's talk. So we look forward to seeing you there.